A histogram is a graphical representation of the distribution of numerical data. It uses bars to show the frequency of data points within specified ranges, known as bins. Here's a detailed explanation. Key features of histograms. Bins intervals. The range of values is divided into intervals called bins. Each bin represents a range of data, and the height of the bar indicates the frequency of data points within that range. Bars. Bars are adjacent to each other with no gaps to emphasize the continuous nature of the data. The height of each bar corresponds to the number of data points, frequency, in that bin. Axes. The x-axis represents the bin's ranges of data. The y-axis represents the frequency of data points in each bin. Creating a histogram. To create a histogram, follow these steps. Collect data. Gather the numerical data you want to represent. Determine bins. Decide the number of bins and their range. The bins should cover the entire range of data. Count frequencies. Count how many data points fall into each bin. Draw bars. Draw bars for each bin with heights corresponding to the frequencies. Example. Let's say we have the following data representing the ages of a group of people: 22, 25, 27, 30, 32, 35, 37, 40, 42, 45. Bins. 20 to 25. 26 to 30. 31 to 35. 36 to 40. 41 to 45. Frequencies. 20 to 25, 2 people. 26 to 30, 2 people. 31 to 35, 2 people. 36 to 40, 2 people. 41 to 45, 2 people. Histogram. Frequency. 20 25 26 to 30 31 to 35 36 to 40 41 to 45. Uses of histograms. Data analysis. Histograms help in understanding the distribution, central tendency, and variability of data. Identifying patterns. They can reveal patterns such as skewness, modality, unimodal, bimodal, and outliers. Comparing distributions. Histograms are useful for comparing the distributions of different datasets. Difference between histogram and bar chart. Histogram represents continuous data with adjacent bars. Bar chart represents categorical data with separated bars. Histograms are widely used in statistics, data analysis, and various fields to visualize and interpret data distributions. If you have any specific questions or need further examples, feel free to ask. Sure. Let's dive deeper into histograms with more examples and a detailed explanation. What is a histogram? A histogram is a type of bar graph that represents the frequency distribution of a dataset. It shows how many data points fall into specific ranges bins. Unlike bar charts, histograms are used for continuous data, and the bars touch each other to indicate the continuous nature of the data. Steps to create a histogram. Collect data. Gather the numerical data you want to analyze. Determine bins. Decide the number of bins and their ranges. Bins should cover the entire range of data. Count frequencies. Count how many data points fall into each bin. Draw bars. Draw bars for each bin with heights corresponding to the frequencies. Example 1. Exam scores. Consider a set of exam scores for a class of students: 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Bins. 50 to 59. 60 to 69. 70 to 79. 80 to 89. 90 to 100. Frequencies. 50 to 59, 1 student. 60 to 69, 2 students. 70 to 79, 2 students. 80 to 89, 2 students. 90 to 100, 3 students. Histogram. Frequency. 50 to 5960 to 6970 to 7980 to 8990 to 100. Example 2, daily temperatures. Consider the daily high temperatures in degree F for a month: 72, 75, 78, 80, 82, 85, 88, 90, 92, 95, 98, 100, 102, 105, 108, 110, 112, 115, 118, 120. Bins: 70 to 79, 80 to 89, 90 to 99, 100 to 109. Thanks for pointing that out. Let's clarify histograms with more accurate examples. What is a histogram? A histogram is a graphical representation of the